In this video, I'll go over the mathematical models that are associated with the chapter on applications of Newton's laws. So first, we have frictional force. So frictional force, remember, we symbolize with the lowercase f. There are two kinds. There's this Fk and the Fs. K stands for kinetic, and S stands for static. Okay, what do those mean? Kinetic, we learned kinematics, right? Kinematics is motion. K is the kinetic friction. That means when something is moving. So if two things are moving relative to each other, there is a kinetic friction force between those two. If they're not moving relative to each other, then it's a static force. So if I have something, so I'm holding a book and it's angled like this, there is static force between my hand and the book. When I tilt enough that it starts to slide, then as soon as it starts, it doesn't slide very well. As soon as it starts to slide, that's when you have kinetic friction. So when it's in one place, that's static. When it starts to slide, now it's kinetic. So the kinetic force of friction is mu, this is this lowercase Greek letter mu, sub k, k again for kinetic, and then n. N is the normal force. So n is the normal force. This mu, that's the coefficient of friction. So the kinetic frictional force is the kinetic coefficient of friction times the normal force. The static friction force, it's not equal to. This says less than or equal to. We'll talk about why that is soon. This is, again, coefficient of friction. So this time is static coefficient of friction times the normal force. And so that means that this is the maximum static force. Static frictional force could be smaller than this number. Spring force, this is called Hooke's law. So here I have a spring. This says the force of the spring is minus k, k is the spring constant, times x, where x is the displacement from the equilibrium position. So here, if I take the spring and pull it this way, and I ask what is the force on my hand that's out here, the force, I can feel it pulling back toward me, right? So the force is toward me, but that x is away from me. That's why there's a minus sign there. So this tells you the force that's applied by the spring on something. So it's minus displacement from the equilibrium position times this spring constant. Now, translational equilibrium. Translational equilibrium means it's not accelerating. So if something is not accelerating, that means the acceleration is 0, and the sum of forces is equal to mass times acceleration. So if acceleration is 0, then the sum of forces has to also be 0. So for something to be in translational equilibrium, that just means all the forces in the x direction and all the forces in the y direction have to be equal to 0. Circular motion. This, remember, is the centripetal force. Okay, centripetal. So the C here stands for centripetal. The centripetal force, notice there is no half arrow above this. So that means this is not a vector. This is the magnitude of the centripetal force. Remember, the direction always points toward the center of the circle. So the magnitude of the centripetal force is the mass of whatever's flying around, like the ball. So the mass of the ball times the velocity of the ball squared divided by r, the radius. That's the distance from the center to the object that's going around in a circle. And force is mass times acceleration. So the centripetal force is the mass times centripetal acceleration. And then if you look at these two, you can see that centripetal acceleration is just v squared over r.